Talk about breakage. Breakage is measuring the tendency of a mineral to break along the zones of weakness due to their atomic arrangement. Simplified, it's the breakage pattern. It's the pattern that a mineral will break into pieces. There are really two types of breakage. There's cleavage, which means that when the mineral breaks, the surface is either semi-smooth with parallel sides or surfaces. So it breaks in a very evenly distributed pattern. If you look at the two samples shown in this picture, you can see this cubic type of breakage, meaning when you break the mineral apart, it does so in this pattern that makes it take this shape. The other type of breakage pattern is called fracture, and this is probably something you would have thought of originally, that if I take a mineral that shows fracture and break it in pieces, it will look like little pieces, like they could all fit back together, but they all have uneven sides. That's what fracture really is. This is probably the most difficult test to perform and observe. So here's a quick video about how to do that.
Okay, so the next test, again, similar to luster, this isn't really a test you're going to do. It's actually probably the hardest property to observe. It's called cleavage or fracture. Now, cleavage and fracture have to do with how a mineral breaks. So again, this is not a test we're going to perform because we're not breaking anything. But we're looking for signs that the mineral breaks along nice, flat, even sides. And if it does, we call that cleavage. If it looks like it just broke off from a bigger piece and it just got all uneven sides, like this sample of gypsum, you could say it has fracture, right? Because it really doesn't have a pattern of breakage. There's nothing spectacular about it. It just looks like a chunk that fell off a bigger chunk. But if I look at this sample of halite, okay, very odd, right? It looks like someone chiseled this off or kind of sawed it off. Actually, this is the way that halite breaks. It breaks in these flat 90-degree angles. So you get this very nice pattern to it. So this is an example of cleavage. Here's another example of cleavage. This is a sample of calcite. It's got rhomboid cleavage, right? It looks like a rhombus if you know your geometric shapes. Slanted, and flat on the top and bottom. And that's exactly how calcite breaks. So here's a really good example of why we need to explore this property. This is Galena. I had shown it to you before when we talked about luster. And when you first look at it, it looks like a chunk that broke off, or another chunk, but it really is a mineral that shows a cleavage pattern. I'm going to zoom in a little bit and get a little bit closer, and if you look carefully, and you'll be able to see this when we do it in class, you can see a bunch of flat raised edges. It looks like a bunch of steps. All right, all those tiny little surfaces are cleavage surfaces. That's a mineral breakage pattern, very specific to Galena. So this is an example of cleavage.
Streak. Now, streak is a very easy test to perform, and it's probably one of the best tests to do. Streak is the finely crushed residue or powder of a mineral, and we test streak using glazed porcelain tiles. So by taking a mineral and producing a streak on either type of tile, we can see if the mineral streak is colored, if it's white, or if there's no streak at all. How that test is performed is shown in this video.
Okay, to perform a streak test, we want to see the mineral powder, the residue left behind when we take a mineral and we rub it against a glazed porcelain tile. I have two porcelain tiles here. One is white, one is dark. And that's because some minerals leave a white powder behind, which looks good on the black. And then sometimes they leave a colored pattern behind, or a colored residue, looks good on the white. Let's try it out. To perform this test, you take your mineral firmly in hand and you try to make a line, pushing with some force, not too much, that you're going to break the mineral or the tile and drag it across. And on the white porcelain tile, that's my mineral powder, my streak. Let's try it on the black. Okay, I have a very different result. And that's why we do it sometimes on two different colored porcelain tiles, because on the white, I really can't tell what color it is, but here on the black, it's clearly a white streak. Let's turn these over. Let's try one more mineral. This is a mineral known as Pyrite. Okay, fool's gold. I'm going to again perform the streak test. Let me try this again. Okay, that's the streak on a white porcelain tile, and then on a black porcelain tile. You can see that it's obviously much clearer and easier to make out here on the white, and that goldish, brassy Pyrite leaves behind a green streak. This is why it's an important test to do, because it's very indicative of what mineral is being tested.
Other properties represents anything that can be used to identify a mineral that's not one of those main ones that we discussed before, those big five. These are in addition to the physical properties that are already visible, that are already observed, but they are very reliable. So the tests that we're going to talk about, the properties we're going to talk about now, are very good indicators. And if you can perform them, they'll tell you exactly what you're dealing with right away. Some minerals, when placed under a black light, an ultraviolet light, they glow, they fluoresce, they give off this appearance. And that's a good indicator of a special property of fluorescence. Another way that we can observe a particular mineral and what it is by looking at an acid test. Some minerals will bubble when acid is placed on top of them. That acid could be hydrochloric acid, sulfuric acid. There are different mineral reactions, but if there are bubbles produced, you can use that to identify what mineral you're looking at. And then magnetism. Some minerals express magnetic properties. So if you can use a magnet and show the polarity or the ability to respond to a magnet, that's a very good indicator of what mineral you're dealing with. So all of the physical characteristics of a mineral that we're talking about, they all fall under the internal arrangement of atoms. So because the way atoms arrange themselves when a mineral forms, that's what gives a mineral its specific characteristics. And those specific characteristics are very useful in identifying them, and that's why we perform those tests. So when we get into class, we'll be using this knowledge to actually go ahead and identify some minerals. That's it for now. Thanks for watching.